Now that I've taught you how to use z-scores and how to look things up and figure out questions like with all these that we did with the fuel efficiency, I'm going to show you how you can use your calculator. And you guys are probably all going to get mad at me and say, why didn't you teach us this to begin with? It's important that you understand z-scores, that you understand what you're measuring with a z-score, that you're talking about numbers of standard deviations above or below the mean. It's important that you know how to use the table because you might find yourself in a class one day in college where you have to use that because your professor might not allow you to use the calculator method. But what I am going to show you and the way I'm going to show you is allowable on the AP stats exam. So I'm not going to redo the model. What proportion of cars get less than 15 miles per gallon? So you're going to draw your picture just like you normally would. And remember that our mean was at 24. So I'm going to label off this direction just like we did before. So this we would have was 18, this was 12, and we were looking for 15. We want less than that. Now, instead of finding a z-score, this is a way that you can avoid that. So on your calculator, you're going to do second, and then hit the VAR, but you're actually after the distribution. And you don't want normal PDF, you want normal CDF. And you're going to choose that. And you have to give a lower bound. Well, the lower bound is negative infinity. So you just want to give something ridiculously low, like -1 times 10 to the 99. You're looking at something that is, low. So, then you're going to have an upper bound, and your upper bound in this problem would be 15. And you have to give a mean and a standard deviation. Notice it's set to 0 and 1, which means if I left it like this, it will give me the z-score that you should have found in your answer when we use the table. But instead, I'm going to put 24 for the mean, and I'm going to put 6 for the standard deviation, and I'm going to choose that. And I get as an answer so the proportion of cars who get less than 15 miles per hour is 0.0668. And that would be your answer. And if you compare this to your z-score answer, now you might find on some of them that they're off just a tiny bit because of rounding on the z-scores. This is actually more accurate. So what do you have to show if you are going to do it this way and not do z-scores? You would have to show what I have in this picture right here. So you have the drawing of your picture with the correct region shaded. You should have something, illustrating that you understand what you're looking for, the proportion of cars. I'm using an X to represent that, less than 15, and then your answer. So on the next one, what proportion of cars get between 20 and 30? So if we mark off, because you still have to do this. So here we had 18, and here we had 30. So we want between 20, so I'm going to pick like here. So you still have your picture. Okay, so how would I write this? I'm going to say 20 less than X less than 30. Then I'm going to my calculator. Second, distribution. Normal CDF. It stands for cumulative distribution function. And that's what you want to use because we're accumulating the area. My lower bound is 20. My upper bound is 30. My mean and standard deviation, the calculator remembers what you just last did. And my answer, 0.5889. I usually go 4 places when I'm doing the proportion. Okay, let's take a look a little more. What proportion of cars get more than 40? So here's my 24. I'm going to go 3 this direction. So we have 30, 36, 42. So I'm going to pick my spot for 40, and I'm shading to the right. And my picture's not the greatest, but so what am I looking for? The proportion of cars that get more than 40 miles per gallon. Now, remember how we had to subtract from 1 and do all this kind of stuff? Well, here, normal CDF My lower bound is 40. I don't have an upper bound, so I'm going to go 10 to the 99. And my mean and standard deviation, and I get 0.0038. So no subtracting from 1, none of that here, because we're just setting our calculator up that way. So that's kind of nice. Describe the fuel efficiency of the worst 20%. Okay, that is just so bad I have to erase it. Okay, not much better, but so we have 24, and we're looking for just the least 20%. So this one you can just pick a spot, and that's actually not very, it should be in the right half. Call this 0.2, okay? Now, so what do I do here? I'm not using normal CDF for this one. For this one, I'm going to use something called, because think about it, we're going the other way. So there's something on your calculator. If you click second distribution, you'll see underneath the normal CDF, you see inverse norm. Well, isn't that a good name for something when you're going the other way? Because you're doing like the inverse operation. So we want to do inverse norm. And then we want, it gives us a little prompt for the area. So the area always has to be to the left. So my area, and I'm going to write that down. So area is to the left. So if I were being asked for the upper 20, the highest 20%, I'd still have to put in a 0.8. I'd put in a 0.8 because I have to put in the area to the left. So remember that. So that's kind of like the picture. Here the mean is 24, the standard deviation is 6, and I get 18.95, and this would be miles per gallon, because notice I have bypassed z-scores when I do this. I'm just bypassing z-scores. So one more, if I wanted to use my calculator to find this third quartile, which is the 75th percentile, so I'm looking for 0.75. Remember, this is when we looked in the body of the table and we found the z-score and we used the formula. Now I go over here, I do inverse norm, I put in 0.75, my area and standard deviation are already there, and I get 28.05 miles per gallon. I'm not going to go on because I think you get the point, but keep in mind, using your calculator does not mean you don't show work. Notice all this. This is work. This is supporting your answer. So you still need to show that. Every once in a while, I practice using those z-scores, but otherwise, this is really nice to be able to use that. Just wanted to show you that.